Hello everyone. In this lesson we will learn the reverse operation of the derivative. It's called the antiderivative. So let's start with some examples. We want to differentiate g, so we say g prime of x equals 3x squared minus 0. So that's just 3x squared. H prime of x is going to be 3x squared plus 0. So that's just 3x squared. Now let's give it a new name. The derivative of g at g prime is f of x, which is 3x squared. The derivative of h, which is h prime or f of x. So we have f of x equals to 3x squared. We're asking the question, what happened before we take the derivative? Before we take the derivative is called the antiderivative, and this is the integral sign. Integral sign will put it back to the function before we take the derivative. So the integral of f of x dx equals to the antiderivative, which is x to the third plus some number c. In the case of g, c is negative 3. In h, c is 7. C is any number or any constant. So the antiderivative of 3x squared is x to the third plus any number c. So g of x and h of x are antiderivatives of f of x. In example 1a, we want to find the antiderivative, so we will write integral of f of x dx equals to the antiderivative of sine of x dx. And the antiderivative of sine of x is negative cosine of x plus some number c. And now let's check. The derivative of cosine of x is negative sine. A negative and a negative is a positive. So we'll give back the function sine of x. And the derivative of c is 0. So if we take the derivative, we will get sine of x. In example 1b, we want to take the antiderivative of 1 over x. So we say the integral of f of x dx equals the integral of 1 over x dx, which is ln of x plus c. Now let's check our answer. If we take the derivative of ln of x, we get 1 over x. The derivative of c is 0. So the derivative of ln of x plus c is 1 over x. And that is the antiderivative. Now let's come up with a formula together. The antiderivative of f of x dx, or the integral of f of x dx, is going to be the integral of x to the n dx. Now remember, when we take the derivative, we subtract 1, and now in order to take the antiderivative, we do the reverse, which is x to the n plus 1. And for the antiderivative, we're going to divide instead of multiply. So derivative, we multiply. Antiderivative, we divide by n plus 1 and plus c. And that is our formula for the antiderivative. So we can write it as 1 over n plus 1 times x to the n plus 1 plus c. And that's how we take the antiderivative. Now let's do example number 2. We're looking for g, and we're going to take the antiderivative of g prime. Integral of g prime of x dx equals to the integral of 4 sine of x plus 2x to the 5th minus x to the 1/2 power all over x dx. And that equals the integral of 4 sine of x plus 2x to the 4th, dividing each term by x, minus x to the negative 1/2 dx. Now we take the antiderivative of sine, that is 4 times negative cosine of x. The antiderivative of 2x to the 4th is 2 times x, 4 plus 1, divided by 5, minus the antiderivative of x to the negative 1/2 is x, negative 1/2 plus 1, divided by 1 over 2 plus a constant c. Now simplify. Negative 4 cosine of x plus 2x to the 5th over 5 minus 2 times x to the 1/2 plus c. In example number 3, we want to find the antiderivative of the function f prime, which is f of x. So let's write f prime like this. F prime of x equals to e to the x plus 10 times 2x all over 1 plus x squared to the 1 power. And now we take the antiderivative, which is the integral of f prime of x dx. And that's going to be the integral of e to the x plus 10 times 2x all over 1 plus x squared times dx. Now we note that the derivative of ln of x, if we take d dx, we get 1 over x. And the derivative of ln of 1 plus x squared is 1 over 1 plus x squared times 2x. So the antiderivative of e to the x is just e to the x because it's the derivative of itself plus 10 times ln of u. In this case, our u is 1 plus x squared plus c, and that is f of x. Now we substitute 0, the condition, for x, and we're going to find out what c is. So we'll do f of 0. F of 0 equals to e to the 0 plus 10 ln of 1 plus 0 squared plus c. We're solving for c. When x is 0, y equals to 2, so f of 0 equals 2 equals 1 plus 10. ln of 1 is 0, so 10 times 0 plus c. 1 plus c equals 2, so c equals 1. So the initial condition when x is 0, our function f of x equals e to the x plus 10 ln of 1 plus x squared plus 1. This is the particular solution for the point 0, 2, the c is 1. Our particular solution is f of x equals to e to the x plus 10 ln of 1 plus x squared plus 1. In example number 4, we need to find the antiderivative 2 times since we're giving f double prime. So the first time the integral of f double prime is going to be f prime, and then we do another antiderivative, which is the integral of f prime. Then we get the function f of x. So let's start. The integral of f double prime of x dx equals the integral of 12x squared plus 6x minus 4 dx. The antiderivative of 12x squared is 12 times x to the 2 plus 1 divided by 3 plus 6x raised to the 1 plus 1 divided by 2 minus 4x to the 0 plus 1 divided by 1 plus c. Simplify, we get 4x to the 3rd plus 3x squared minus 4x plus c. And that equals f prime of x. Now we take the antiderivative one more time. So the antiderivative of f prime of x will give us f of x. The antiderivative of 4x to the 3rd plus 3x squared minus 4x plus c. And don't forget the dx both sides. So now the antiderivative of 4x to the 3rd, we add 1 to the exponent and divided by 3 plus 1 is 4, divided by 4. Plus 3x, 2 plus 1 is 3, so we divide that by 3. Minus 4x to the 1 plus 1, that's 2, so we divide it by 2. Plus c times x, plus some number k. And that is f of x. Now we simplify. F of x equals x to the fourth plus x to the third minus 2x squared plus cx plus k. Next, to get c and k, we need to use the initial conditions given. F of 0 equals 0 to the fourth plus 0 to the third minus 2 times 0 squared plus c times 0 plus k equals 4. So we know k equals 4, and that is the value for k. To find the value for c, we plug in 1. So f of 1 equals 1 to the fourth plus 1 to the third minus 2 times 1 squared plus c times 1 plus 4. And when we simplify, we have 2 minus 2 plus c plus 4, and f of 1 equals 1. So cancel the 2 minus 2, and I have c equals negative 3. Now we found the value for c. Now our final answer is f of x equals to x to the 4 plus x to the third minus 2x squared minus 3x plus 4. And that is our particular solution for the given initial value. Good luck on your homework, and I will see you in the next video.